If I look at the next one, I want to rewrite this using rational exponents. So for this one, to rewrite it as a rational exponent, I just want to write the exponent as a fraction. So this is the same thing as x to the what power. And really remember, the exponent is the numerator, the root is the denominator. So that's the same thing as saying the 8/3 power. And that's it. For number 16, I'm going in reverse. Now I have a rational exponent. I've got x to the 4/7 power. I'm going to rewrite it in terms of a radical symbol. So when I do this, again, the numerator is the exponent, so it's n x to the 4th underneath here. The denominator is a root, so it's the 7th root of x to the 4th, and that's it. If I look at the next one, I want to simplify this using the rational exponents. And just remember that the 1/2 power is the same thing as the square root. So when I do this, 49 to the 1/2 power is 7 because it's the square root of 49. Okay? X to the 12th, if I take the square root of that, I'm dividing, or you can just think of it as multiplying the exponents. That's an x to the 6th. And then the y, that's going to be a y to the 3rd. But again, if you need to, if you have trouble thinking about these, just think of this as the square root of 49 x to the 12th, y to the 6th. And now it should be pretty simple. Okay? Same thing with the next one. The 1/3 power is the cube root. The cube root of 27 is a 3. The cube root of x to the 18th, again, I'm multiplying by the 1/3 or dividing by the 3. That's an x to the 6th, a y to the 3rd, and a z to the 4th. Okay? And again, when you're looking at these, you can just think of them in terms of radicals. If you want, you can think of this guy as just the cube root of 27, x to the 18th, y to the 9th, z to the 12th, and go from there. Okay? If I look at this one, I want to solve for x. Remember, to undo radical symbols, to undo roots, I have to use exponents. So to undo the square root, I'm going to square each side. I'm going to raise each side to the 2nd power. I'm not multiplying by 2. I'm raising it to the 2nd power. So over here, the root and the exponent cancel out. I'm left with a 2x. Over here, 4 to the 2nd power is 16. And now I divide each side by the 2. And the last thing I should always do is plug this in and double check. So I plug it in. 2 times 8 is a 16. Square root of that is 4. It works. Okay? Always check for extraneous solutions here. Number 20. I've got to isolate the radical first, so I'm going to subtract the 5 from each side. So that's going to leave me with a cube root of 3x equals a 3. And now to undo the cube root, I have to raise each side to the 3rd power. Okay? To undo roots, I have to use exponents. So that's going to leave me with a 3x equals 3 to the 3rd power is 27. And now I divide each side by 3. And I find out that x equals 9. And of course, I got to plug it back in. So I plug it in. 3 times 9 is 27. Cube root of that is 3. Plus 5 is an 8. It works. Okay? Make sure you plug it back in and make sure that it works. For this one, I'm going to subtract the 3 from each side. Again, I isolate the radical first. I got to get that root by itself before I can undo it. So negative 2. And now to undo this, to undo the 4th root, I raise each side to the 4th power. Again, we undo roots with exponents. So that's an x plus 1 equals negative 2 to the 4th power is a positive 16. And now I subtract the 1 from each side, and I find out that x equals 15. And of course, I plug it back in to make sure that it works. So 15 plus 1 is a 16. The 4th root of that is 2. 2 plus 3 is a 5. So 5 equals 1. Uh-oh, that's an issue, okay? And really, we've done nothing wrong. You can go back, double check your work. This is an extraneous solution. X cannot equal 15, which means the only solution I had was extraneous, which means the answer to this guy is no solution, okay? The only answer I had was extraneous, so it's no solution, okay? Please check for extraneous solutions. If I take a look at the next one, again, I've got to get the radical by itself. I'm going to divide by the negative 2 first. So that gives me the square root of 2x minus 3. Now to undo the square root, I have to raise each side to the 2nd power. I undo roots using exponents. So you've got to use exponents here. So the root and the exponent cancel each other out. Over here, I've got a 25. I'm going to add the 3 to each side. So I find out that 2x equals a 28. I divide each side by 2. And I find out that x equals a 14. And of course, I plug it back in and check. 2 times 14 is a 28 minus 3 is a 25. Square root of that is 5 times negative 2 is a negative 10. It works. Okay? Plug it back in and check it. Okay? If I look at the next one, again, I add the 2 to each side. So I've got the square root of 5x plus 1 equals 4. To undo the square root, I have to raise each side to the second power. Roots and exponents cancel each other out. So I've got 5x plus 1 equals 4 to the second power, which is 16. And I finished solving this. I'm going to subtract the 1 from each side. So I've got a 5x equals 15. I divide each side by the 5. And I find out that x equals 3. And then I plug it back in and check it. 5 times 3 is a 15, plus 1 is 16, square root of that is 4, minus 2 is a 2. It works, okay? So make sure you check for extraneous solutions. If I look at the next one, we've got the square root of a negative here. Remember, when we're doing square roots of negatives, this is when we deal with I values. So let's break it down this way. I'm going to do the same thing I did before, except negative 1 is one of my options now. So the 75 I can break down into 25 times 3. But then it's a negative 75, so times a negative 1 as well. And now as I take the square root of each of these things, the square root of 25 is a 5. The only other thing that I kind of know how to take the square root of is the negative 1. The square root of negative 1, this is where we get imaginary numbers. The square root of negative 1 is an I. And I use my little banana peel I. And still trapped under my square root is a 3. And that's it. Okay? Everything's exactly the same, except when I see a negative, I take the square root of it as an I. Okay? When I'm dealing with operations with I, like number 25, I'm subtracting. If I'm subtracting, I'm really just combining like terms by subtraction. If I'm adding, I'm combining like terms by addition. And I would just change this to adding the opposite, just to make it easier on yourself. So I change subtraction to adding the opposite, and now I combine like terms. The 3 plus 2 is a 5, and then the 4i plus the 3i is a plus 7i. And I just treat I like a variable. I know it's not a variable. I know it's an imaginary number, but I treat it like a variable when I do operations. Same thing with number 26. Number 26, I've got a distributor FOIL here. So I'm going to distribute the 8. 8 times the 2 is a 16. 8 times the 3i is a 24i. Again, I just treat it like a variable, as if it was an x in here. And now I distribute the next term. The negative 2i times 2 is a negative 4i. The negative 2i times the 3i is a negative 6i squared. Okay? If it was an x, this is what I would have done. If it's an I do the same thing. The only difference now is I have to remember that I is actually a number, and that I squared is actually a negative 1. So I'll break this down in a couple different steps. Let me combine like terms. So I've got 16. That's going to be plus 20i minus 6. But I squared is actually a negative 1, so plug a negative 1 in its place. Okay? We have to simplify these because they're numbers. We have to simplify them as far as possible. That's going to give me a plus 6. And now I have more like terms I can combine, which means this is going to be a 22 plus 20i. Okay? We deal with it just like we would variables, but then we have to remember to take care of those powers of I. Okay? If I look at this one, I want to rationalize the denominator. If I have a binomial down here, I have to multiply by the conjugate, just like I did when I was simplifying radicals, because that's all this really is. Okay? I is just a square root of a negative 1, which means I is a radical, which means I just have radicals here, and I deal with them the same way. I multiply by the conjugate. Whatever I do to the denominator, I do to the numerator. And now, in the numerator and denominator, I have to distribute or FOIL. So up top, I distribute the 4. That gives me an 8 plus 20i. I distribute the 4i, which gives me a plus 8i plus 20i squared. In the denominator, I distribute the 2. That gives me a 4 plus 10i. I distribute the negative 5. Gives me a minus 10i minus 25i squared. And now I deal with these powers of I. I start simplifying. In the numerator and denominator, I can combine like terms. That gives me an 8 plus 28i. And then right here, keep in mind that I squared is a negative 1, which means if I have 20 times a negative 1, it becomes a negative 20. Okay? It's the same thing in the denominator. I combine these like terms. They just cancel out, which is awesome. I've got 4, and then right here, I squared is a negative 1, which means I have negative 25 times a negative 1, which is a plus 25. And now I finish combining like terms, the 8 and the negative 20, the 4 and the 25, and I find out that I have a, let's see, a negative 12 plus 28i all over a 29. And then I look to see if I can reduce this fraction at all, which I can't, so that's my answer. Okay? And so I've gone from having radical symbols, or essentially imaginary or complex numbers in the denominator, to having real numbers in the denominator. Okay? Number 28, a couple of different ways you can approach this. The easiest thing to do is just to multiply numerator and denominator by I. So I'm going to multiply by I over I. In the numerator, I have to distribute that I, which gives me a 4I plus 7I squared all over 2I squared. And now I have to simplify things again. I squared is a negative 1. Same thing down here. I squared is a negative 1. So I have to simplify that. It becomes a 4I. That's going to become a minus 7 over, this is going to become a negative 2. And now I'm going to rearrange some things because typically I have the real part listed first, so I would rearrange it like this. But then also I typically wouldn't keep a negative in the denominator, so I'm going to divide everything by negative and rewrite this as 7 minus 4I all over 2. Okay? Some of you probably approached it this way, and this is fine. You will get the same answer. You'll just have a little bit of an extra step in here if you multiply by itself by 2I over 2I. That's fine. That will give you an 8I plus 14I squared all over 4I squared. And then through the simplifying process, you're still going to get to the same thing, 8I minus 14 over a negative 4. And now as I simplify this, everything's divisible by a negative 2, which gives me a negative 4I plus 7 all over a positive 2. And if I flip-flop that numerator, I'm back to the original answer that I got before. Okay? I hope this was helpful, and good luck on your test.